Good day, welcome. We are looking at geometry and we will be looking into congruency and similarity. When we speak of congruency, we need to understand what congruency means, and when we speak of similarity, we must know what similarity means. When we speak of congruency, we need to understand that two shapes are being compared. It can be triangles, it can be quadrilaterals, it can be any given shape. These two shapes are compared, and if all the sides and all the angles are equal, then they are congruent. If one shape fits exactly on the other, or when an original shape was translated, rotated, or reflected, but not always will the reflection be congruent to the original shape. I take an example. Here I have a rectangle. Here I have another rectangle. If they fit exactly on each other, they are congruent. These two rectangles are congruent. I see nothing of the original shape, and it fits exactly onto the other shape. I bring another rectangle into play here, and if I rotate this rectangle, I will see whether they are congruent, and I see that this rectangle is congruent to this rectangle, is congruent to that rectangle after being rotated, and this one after being slided or translated. So translation means shift left or right, down or up. That's a translation. A rotation is when an object is taken and turned about a point. That's a rotation. Okay, so let's put it back there. I would like to show you with triangles also. So if I rotate this object to fit exactly on the other, I can see those two triangles are congruent to each other. Don't fit it so nicely now. There we go. And if I reflect this one, so if I flip him over, then that will also be so the reflection being flipped over shows me that these triangles are all congruent. So if an object is translated or rotated or reflected and they fit exactly on each other, then the two shapes are congruent. What can we learn from this little experiment? Sometimes it may be necessary to rotate and translate an object, but sometimes it will also be necessary to firstly translate the object and then rotate the object. And then there will be other times, especially when there's a reflection involved, that the object might need to be translated and or rotated before we reflect it. Let us quickly look at a practical example of what a translation means. If this is my original shape and I translate this 2 units down and 7 units across, 1, 2, 3, 4, 5, 6, 7. So my translation happened 2 units down and 7 units across. That is, that point moved units and 7 across. That point moved 2 units down and 7 across. This point moved 2 units down and 7 across. That point moved 2 units down and 7 across. So that is a translation, also known as a glide. So let's look at the second one. if I reflect this object in the line y is equal to 0, or commonly known as the x-axis, that means this one goes 3 down to the mirror, so it needs to move 3 away from the mirror. This one moves almost 5 to the mirror, so he must move almost 5 away from the mirror. So when I draw my picture, so if I take my picture 3 to the mirror, and then 1, 2, 3 away from the mirror, that means if that is the mirror, this picture is reflected about the x-axis. What would happen to this shape if it is reflected about the y-axis? So it goes 1 to the mirror, and then it is being reflected about the y-axis. So the distance that it is away from the mirror there must be the same distance away from the mirror. The distance that that point is away from the mirror, that point must be away from the mirror. The distance that this one is away from the mirror, the same distance that one will be away from the mirror. And you will see that that is how that particular reflection works. Then we have another type of transformation. And this transformation is a rotation. Now, a rotation can happen about this point, it can happen about that point, that point, that point, or any other point on the Cartesian plane. Generally, it will be through the origin. But for purpose of this exercise, I would like to do a rotation of this shape through that point. So if I rotate this object, and I've rotated it at that point, the new shape will then take form and it will stand over there. The original point moved around, so that will remain because it's a reflection in the point 1 and 3. So this shape will just merely be tilted there and it will form the new shape. The next reflection that I would like to do is a reflection in the line y is equal to x. And this says exactly what it is. Whatever the y value is now becomes the x value. Whatever is the x value now becomes the y value. But I want to demonstrate this. So if I have to reflect this original shape about the line y is equal to x, I count how far must I go to the line. 3. I'm at the mirror. A mirror reflects at 90 degrees. So that point there, let's call him A, will now be point A over here. This guy, how far is he away from the mirror? 1, 2, 3, 4, 5. And at the same spot, you see, he does not reach the line. He will be just before you reach the line. So he will go 5 down. 1, 2, 3, 4, 5. That will be my point B. Now I'm going to go to point C. So, how far is he away from the mirror? I count 1, 2, 3, 4, 5, 6, 7, 8, 8 and a bit. So that bit will be represented here, and now I count 8 away. 1, 2, 3, 4, 5, 6, 7, 8 away. So in line with B, but 8 away. Then my last point D. How far is he away from the mirror? 1, 2, 3, 4, 5, 6, 7. Then he must go across. Count again. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. And you will see that he is in line with A. So I think I counted wrong over here. So let's just double check this one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This one will be 9. 7, 8, 9 away. So there's my point C, and there's my point B. If you look at the shape now, you will see that this takes the form of this, more or less will be the shape if it is reflected about the line y is equal to x. Notice also the position. All my x's became my y's. So as this object is 2 away from the x-axis, it is now 2 away from the y-axis, and the one that it is away from the y-axis, it's now 1 away from the x-axis. Notice how it plays out in this instance. Another reflection that you could potentially work with is a reflection in the line y is equal to negative x. Just extend it a little bit further. If I have a reflection in this line, then all I do is, how far do I go to the mirror? How far must I go away from the mirror? Let's use a different color. Let's use blue. So this one goes 1 to the mirror, 1 away from the mirror. This goes 1, 2, 3, 1, 2, 3. So there's my A dash, and there's my B dash. So now I must do C dash. So C goes 1 to the mirror, 1 away from the mirror. Always at 90 degrees. So C dash will be over there. And then I go to D dash. 1, 2, 3 to the mirror. So it goes 1, 2, 3 away from the mirror. So then I have D dash. And my shape will still remain in the same form as what this shape used to be. You will notice that C does not touch the line CD, and in the same instance CD won't touch the line in this instance also. So we have the same position as what the original rotation was that I had. So that is reflections in the line y is equal to x and y is equal to negative x. We continue to explain the concept congruency. So if I have one shape and another shape, and the other shape covers that shape exactly the same, then those shapes are congruent to one another. Yeah, I can see there was a rotation that happened, and the object covers the other object exactly. Do another example. That one goes on top of that one. This one, let's rotate him 90 degrees to the left. He covers that one exactly. And this one, if I put him in there, he hides exactly behind the seam there. So those are all congruent shapes. So the explanation of congruent is all sides are equal and all angles are equal. The symbol for congruency is 3 lines in the same shape as an equal sign. Let's see, can you find whether these two triangles are congruent or not? Seemingly, when I calculate the angles, I see they have the same angles, because the angles of a triangle add up to 180 degrees. These two angles are complementary, adding up to 90. But I cannot say. I had to have more information. If that was 12 centimeters and this side was 12 centimeters opposite the same angles, then these two triangles would have been congruent. There's quite a bit of work still to cover on this topic, so I will have another video explaining more concepts about congruency. If you liked the video, share with your friends. If you loved it, tell everyone. I will see you in the next video.